This is our final unit for general forensics this year. It deals with firearms, tool marks, and impression evidence. So, what we're going to talk about first in this unit is really different types of firearms, but firearms are a smaller grouping under impression evidence. So, impression evidence is going to be when a harder object comes in contact with a softer object and then leaves some sort of mark in it. So this could be a footprint, a handprint, a bite mark, scratches, things made by tools such as a bolt cutter, and then firearms. We're going to see because there are different parts of the firearm that come in contact with each other and can leave evidence behind. So, with that in mind, let's get started. First thing is it's good to have a background on how some of this technology developed. So, historically, it began with the invention of gunpowder, which was in the 9th century in China. Some things that we might look for in a chemical analysis to find out if gunpowder was present would be carbon, sulfur, and potassium nitrate. And there are other compounds as well. Uh, Very early weapons that were used were sometimes called hand cannons. And so basically, the gunpowder was placed in the end of a tube, and then some sort of projectile was put into the end of the tube, and then they had to light that gunpowder through a small hole, and then that would be projected. So over time, different parts of this process were modified and improved. So starting with gunpowder, being able to have it burn faster, more reliably. Um, Imagine trying to light your gunpowder and it will not ignite, and then having higher power. So firearms spread throughout the Middle East and Europe as early as the 1300s. But where we're really going to start is talking about the 17th century with something called a flintlock. So this is a early flintlock system, and basically, what is going to happen is uh, there's a pan which is outside of the gun. They're going to put some gunpowder in there, and we need to ignite that gunpowder. Now, prior to this, they might have used something called a match lock. So the lock is this part here, where when you pull the trigger, it's going to come down and come into contact in some way with the gunpowder. So in the case of a flint lock, the flint is this material that when it hits a metal plate called a frizzen, it creates sparks. And you've probably seen this before where something strikes another object and sparks come off of it. Those sparks hit this gunpowder, the gunpowder ignites, and it goes through this little hole. And then internally, that's going to ignite the gunpowder that's in there. And that explosion is going to send the projectile out through the barrel. So this area here is called a primer, and then internally, inside this gun, would be the main charge. And so this part was called a frizzen. In the case of a matchlock, they would literally light a fuse here, and then that would be brought down to touch this and ignite it. So you can imagine there's some problems with this. Imagine that you're hunting or in wartime, you have bad conditions and it's raining and that material gets wet. There's wind that could blow out the match or blow this around. It's slow to fire. And after you've done it, you've got to basically have the whole setup again. So there were some drawbacks to that as well. And then safety as well. You're lighting that gunpowder externally and you're holding that up a lot of times near your face. There's two general things we can say about how a gun might be loaded: muzzle loading, or what's called breech loading. Muzzle means that you're going to take and put everything down the opening of the barrel. So you've got sort of that length of pipe, and you're going to cram everything down in that from the opening on the end where the bullet is going to come out. Okay, so that would be what a muzzle loader is. And an example of that might be the flintlock or the matchlock. Okay, so again, where they're going to have to do load everything down. So it's a slow process to do that compared to modern, what might be considered modern firearms. Breech loading is going to put the ammunition directly in what's called the firing chamber. So in this case, we have what's called a break action, which means that the barrel can come away from the end here, which is going to be the firing mechanism. And so here we can see in a little bit more modern one, they're putting the round of ammunition directly in the back of the gun, and that's called breech loading. So moving on from having an external set of gunpowder, maybe in a pan in this area, they developed something called percussion caps. So these are small little metal cases. We see some examples here, and they have a chemical compound in them. Often it's called mercury fulminate, and if you strike it with the right amount of force, that shock of it, that impact, will actually detonate it. And so what would happen is you would have gunpowder internally, which is going to be what explodes and sends the bullet out through the end. But right here, they would put a little percussion cap. Now, this part here is the hammer. So you would cock it back, which means they'd pull this back, pull the trigger releases that, it comes down, and that strikes the end of this. And that striking um, causes this to ignite internally that gunpowder. So previously, maybe sparks were igniting gunpowder externally, or a match was igniting it externally. In this case, it's striking this cap, and that is keeping it internal. So there's some benefits to that as this hammer strikes that cap. You don't have to worry about the weather quite as much, and these are a little bit quicker, maybe, to reload. And so this sort of offers a transition between muzzle loading and breech loading weapons. Fixed ammunition is really what we think of mostly today, although all these types of firearms exist today, and there's even more modern versions of them. But what it does is it combines something called the primer with a charge, which is the internal amount of gunpowder, and then a bullet. And this is a watertight container. So that's what a round would be called. It's really the combination of all these parts. So we have a casing that's going to hold it all. We're going to put powder down into it. We're going to add the bullet as a piece of this. And then the primer is inserted in the end. So that primer is still going to be struck similar to that percussion cap. It's going to ignite the powder inside. That's going to cause an explosion. There's going to be no place for this bullet to go but out the end of the gun if it's functioning properly. So these tend to be breech loading. Now, looking at the barrel itself, right here we're looking down the end of the barrel, which is not something you would normally want to do. There's a lot of safety precautions that you want to consider when handling a firearm. But you can notice this one is called a smooth bore. And the bore is really the hollowed out part of the pipe that we would call the barrel. So in this case, it's literally smooth. And in this case, we see that there are some ridges in it that are raised or indented. And there's different types of that, but that's called rifling. And that's where the term rifle comes from. So you might think of a rifle just as the firearm, but rifle actually refers to this pattern which is inside the barrel. And you see here, it sort of sets up like a spiraling. What that's going to do is as the bullet is traveling down through the barrel before it leaves the end, it's going to cause it to spin. So think about a football that's thrown. If someone puts a spiral on it, it sort of stabilizes it for its flight through the air more. It is going to be more accurate. There are different ways to strike this round of ammunition for it to detonate and fire. So one of them is called center fire, and this is where something called a firing pin is going to strike the primer, which is at the center of the cartridge base, and it is the most common in use today. So right here, there is a picture, and we can see there's a little indentation right here in this round of ammunition. What has happened is the trigger was pulled, and internally, when you pull that trigger, kind of like the hammer before coming down and striking that percussion cap, a pin impacts the center base here. And this is the primer. So striking that, there's a sensitive material in here that is then going to ignite the gunpowder internally. So by striking the center of this primer, we ignite the powder explodes, and this bullet then is released from it, travels down the barrel, and then leaves the firearm. Rim fire means that that shock sensitive material is in the outer lips here, okay, or the ring of it, or the rim. And so we can see if this thing's going to disappear here. If you look at this one, down at the base, there was a little indentation. So it was struck on the rim and then ignited this internally. So that's a little bit of a historical background. Now, if you are not familiar with firearms, the amount of vocabulary can be intimidating, but let's start with just a basic definition. What is a firearm? It's an assembly consisting of a barrel and an action that propels a projectile by the products of combustion. It's a short definition that really covers everything you need to understand about it, but there's some vocabulary in there. So, what's an assembly? It's putting all the parts together, right? So, one part of it would be the barrel. So, that's the hollow pipe that the ammunition is going to be fired through. An action is going to be the type of mechanism that is going to really fire the bullet. Okay, so there are different types of actions, and that term is used in a couple of different ways. But you could have a pump action, a lever action, a bolt action, and others. And then the projectile is what we would think of as the bullet that is going to leave the gun. Now, there are other things as well. For those of you familiar, so you think about a shotgun. Shotgun in general is going to eject pellets, although it could use a slug. So again, there's a lot of different types. The products of combustion, what does that mean? It means igniting the gunpowder and causing an explosion. Generally, combustion means burning with oxygen. And in this case, if we rapidly burn the gunpowder, that is really an explosion. The difference between burning and an explosion is really the speed of this type of chemical reaction. So we're going to ignite this gunpowder, it's going to explode, and there's no place for that pressure to go except out the end of the muzzle or out the end of the barrel. And so that projectile is propelled down the length of that barrel and out the end. Where is this taking place? That explosion occurs in a part of the firearm called the chamber. So that is where the ammunition is loaded. And once it explodes, there's one direction for the escape of the pressure, which should be the end of the gun here. So the projectile has to fit tightly into the walls of the chamber, so it creates basically a seal. And again, everything's a little more complicated than this, but for now, let's just maybe oversimplify it to get the basics, and then we'll build our understanding from there. So, when the explosion occurs, the energy of the escaping gas sends the projectile down the barrel. So, where is that force coming from? Again, it's coming from the gunpowder and that chemical reaction of combustion. So, right here, we can see a handgun. In this case, it's a pistol as opposed to a revolver. We can see that there are multiple rounds of ammunition prepared, and one at a time is loaded into the chamber. So we can see one is in the chamber, ready to be fired. Here's a firing pin. And in this case, when this strikes the base of that round of ammunition, the gunpowder inside will detonate. This end will be released. It will travel down the barrel and be fired. So this part here is the actual projectile or bullet. This whole thing is a round of ammunition. The part that's left behind is the shell. Sometimes they call it the brass because often this is composed of the metal, brass. And this is then going to be ejected from the firearm, and then we're going to load the next one into the chamber. So there are three basic handgun designs, or excuse me, gun designs. A handgun, which would be a pistol or a revolver, most commonly, but there are other types, such as one called a derringer. Rifle and shotgun are types of long guns. So what's the difference? A handgun, when used by the manufacturer's specifications, is meant to be fired using just your hands. A long gun, when used by the manufacturer's specifications, is normally intended to be fired from the shoulder. Of course, there are exceptions to this, but that is the general concept. So, a rifle and a shotgun are both types of long guns. So, the handgun, specifically designed for operation using one hand. However, based on the power of the gun and stability, generally people are going to have two hands on this firearm. Now, what do these include? Derringers, pistols, revolvers. Derringer may be one that most people haven't heard of. It generally here is going to have two separate barrels, and we're not really going to talk about them much because they're not very common. And this is just an introductory course and topic. Pistols and revolvers. They're far less accurate um, compared to, say, a rifle because of shorter barrels. And so the longer the distance, the less accurate this is going to be. A pistol has the barrel and a chamber as one solid piece, and reloaded using something called a magazine, in which we see here. Sometimes in movies we hear these things referred to as clips. Technically, that's not a clip. A clip is usually used to reload a magazine. A magazine is a device that contains a spring, and you load it with different amounts of ammunition. And based on the type of gun design, that could be just a few or several. And based on what state you live in and federal guidelines, there are regulations in terms of the legality of how many that those can hold. But basically, what's going to happen is once the ammunition has been fired, this device loads a new round of ammunition so that when I pull the trigger, once it fires, it loads the next round of ammunition. I pull the trigger again, it fires again. And that differs from early designs where you had one round of ammunition, you pulled the trigger, fired it, and then you had to do the whole setup again. This allows you to fire and fire and fire until you have run out of ammunition. Then this magazine here normally loads into the base of this here, so it would snap up into here, and then you can release it, reload this, and put it back in. The revolver has the ammunition in a cylinder. So we can see here that this one is holding 6 shots. There's different types. Typically, it's between 5 and 8, but in this one, we see 6. So what's going to happen is one of these is a chamber. So this has 6 different chambers here. The chamber is going to be in alignment with the barrel. So when you pull the trigger and it strikes this, it's going to fire that out the barrel. The cylinder is then going to rotate and click the next one into place. And so every time you fire, this cylinder is going to turn and load up the next one. Semi-automatic. Okay, so we hear things about automatic, semi-automatic, fully automatic, machine guns. Some of these terms are used in different ways depending on context, but in this case, semi-automatic means that the energy that you released when you fired actually ejects the spent casing and then reloads a fresh one into the firing chamber. So the simplest way to think about this is when you pull the trigger once, you fire one bullet. So if you go click and pull the trigger and it goes bang, and then you're holding down the trigger and nothing's happening, and you release the trigger and you pull it again and it goes bang, that is semi-automatic. As fast as you can pull the trigger is as fast as the gun can fire. And so pulling the trigger in one motion fires this, sends the bullet out the end, ejects the cartridge, loads the next one, and you're ready to go. And then you pull the trigger again. Automatic means that you get multiple shots fired for one trigger pull. So if you hold down the trigger, as long as you're holding it down, and as long as there is ammunition being fed in, it's going to go bang, 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 bang. It's going to fire multiple times for one pull of the trigger. That is what is typically meant by an automatic weapon. Long guns are intended to be fired using 2 hands. They have a longer barrel, typically, at least the ones that are legal. You hear of things like sawed-off shotguns, and we'll talk about the legality of that eventually. But the longer barrel allows it to be more accurate over a longer distance. Now, that long gun may or may not have rifling, those grooves that are inside the barrel that are going to cause that bullet or projectile to spin. This is called gyroscopic stabilization, which just means spin, and it gives it better flight properties through the air for better precision and better accuracy. It really provides stability for that round to, or I should say that bullet to travel through the air. So again, picture a spinning top, a spiraling football, in this case, a spiraling bullet. This rifling is going to be really important for us in forensics because those raised areas and those depressions are going to leave marks on the bullet itself. And if we can recover the bullet and we can recover the firearm, we can then do a test that compare the two to match that this bullet was fired from this firearm. So rifling can individualize a weapon. So you may recover some ammunition, and that's going to tell you a class characteristic about the weapon. In other words, a big general grouping, but it's not going to tell you that this particular bullet was fired from this specific firearm. And that's really what we want to do. Rifling can make that possible. And these are things called lands and grooves. Grooves are where some of the barrel has had its metal removed to create a depression. Lands are the raised edges. And so generally, there are 2 to 8 of these grooves when you look at rifling. Now, there are different types of rifling, but in this case, let's just look at this. This indentation right here would be a groove. This is a raised edge. The bullet is going to fit snugly into here. So as it travels down, it gets spun by this, but it's also scraping that bullet, which is softer than the material around it, and it leaves an impression on it. So remember where we started all this, we said bullets are going to be a form of impression evidence. The barrel of the gun literally scrapes onto the bullet and leaves marks on it that can be matched to this. Notice here we have a certain direction of what they call twist. You can have a clockwise twist or a counterclockwise twist based on the type. There's also not just this type of rifling, but something called polygonal rifling, which is a little bit different. But handedness of the twist is going to cause the bullets to either spin in a clockwise or a counterclockwise motion. American rifles traditionally spin bullets to the right. Um, British rifles often have a left-hand spin. There are other countries, obviously, that manufacture these. This is just a generalization to give you two examples. The twist rate, the length of the barrel needed to make one full rotation of twist. So you're going to spin that bullet um, one whole turn, 360 degrees. So, for example, if I needed to spin that bullet once in 10 inches, that would be a 1 to 10 twist. The shorter the distance, the faster the bullet is going to spin. Now, notice here at the bottom that the bullet is fitting into the barrel nice and snug. And I'm going to move my cursor away here so you can see what's beneath it. But you'll notice that the shell casing is larger. The shell casing remains behind. Only the bullet leaves. So that shell casing then has to be removed from the firearm. Generally, that is done automatically by the weapon. Sometimes they're left behind. So in the example of the pistol, when you squeeze that trigger, it's going to fire and eject that shell casing. But in a revolver, that shell casing is going to be left behind in the cylinder because the cylinder rotated and kept it. So that means some things for us forensically. If the person who fired the weapon did not pick up their shells afterwards, they left them behind for us to gather as evidence. But in the case of a revolver, often those shells are not left behind because they are in the gun. So unless they opened it up, dumped them out, and left them behind, which would be really lucky for us in forensics, you're not going to find that evidence. So here's some examples of different twist rates. Okay, so these rifling features are imprinted on the bullet from the gun, and it helps identify the gun type for that particular bullet. So what we see here is called comparison microscopy. We talked about that really early this year, but basically what you do is if I have two bullets and I put them under two different microscopes at the exact same time, and then I have a device that allows me to look at both pictures from both microscopes at the exact same time, I can compare those two pictures and I can see that these markings line up perfectly. That is the same gun firing the same bullet. That's the idea. We're going to talk about that more later on in this unit. Polygonal rifling is going to have a multi-sided shape as opposed to the lands and grooves that we talked about earlier. So we only mention it here to say that that exists. We're really not going to cover it much because, again, we have to limit ourselves because there's just so much. You could spend a lifetime studying this topic. Generally, why do they use polygonal rifling? It's fast and inexpensive to manufacture. One of the consequences is it's smoother, leaves fewer marks, but they do have characteristic striping patterns that they do leave on the bullet. Those are called stria. We'll talk about that more at a later time. So barrel lengths for guns. In the US, the minimum legal length is 16 inches when you're talking especially about a long gun. So we'll talk about legality more in a later time. The firing mechanism can be what's called single shot, semi-automatic, or fully automatic. So we've kind of mentioned those already. Single shot is you pull it once, it fires, and now you have to reload. Semi-automatic, pull the trigger once, it fires once every time you pull the trigger. Fully automatic, I pull the trigger once, it fires multiple times as long as I'm holding down that trigger. Shotgun is a type of long gun, and we normally talk about them based on what they're firing, which is a little bit different way of thinking about it. The barrels are normally smooth, so they're normally not rifled, but there are shotguns that do have rifling. So again, we can't be all black and white about it. Ammunition can typically contain many small pellets, which are called shot, and those can be different sizes, but they're contained within a single cartridge. Or you could have a single solid projectile, and in that case, it's usually called a slug. So when we talk about the size of the shot that's being used, this is called the gauge. So you might have heard of, for example, a 12 gauge shotgun. The diameter of the shotgun's barrel that's equal to the size of the balls that are needed to weigh 1 pound is the technical definition. So that can be a little confusing. If you have questions, let me know and I will help clarify that. But for example, if I had a 12 gauge shotgun, the barrel is roughly the same diameter as a single ball that would weigh 1/12 of a pound. So again, that may not be real clear to you right now. And just for the sake of trying not to make this video any longer than it already is, we'll come back to that topic. Here's the big difference though. The shot scatters as it leaves the end of the barrel. And so it's going to have a different spread based on distance. So the pattern is going to spread out farther you are from a target and be closer together the closer you are to a target. Air guns are, now notice this, it's in quotes, firearm-like. It doesn't actually meet the definition of a firearm. And that's why you might be surprised that the legality of these are a little bit different. They move a projectile, but instead of doing combustion, instead of that chemical reaction, they're using stored pressure, so a CO2 canister. And there's some other methods and some other gases that can be used. But compared to firearms, they tend to be less powerful and less accurate over longer distances, but they can be lethal, they can be deadly, and they can be used in crimes and have forensic significance. We're not really going to talk about them much because they're not the most common thing used, and they don't fit the definition of a firearm. So we are going to limit ourselves in this really to talk about firearms. Okay, but there are some different options for that. And then they can fire different things. Doesn't have to be a bullet, could be a paintball, for example. So we're going to end here. We're going to do firearm definitions and all the parts in a separate video.